Good day, students. Today the topic of our video is input transducers. Input transducers we discussed in the last class. Transducers. Do you remember that? Transducers are the devices which convert one form of energy into another form of energy, right? And then we discussed that there are two categories of transducers: input transducers like mic and output transducers as a speaker. The two types of transducers which are included in IGCSE syllabus are light dependent resistors or LDR in short. One type of input transducers discussed in your IGCSE syllabus is thermistor. Page number are mentioned over here for your convenience, so you may refer to both pages. Okay, so let's start our lesson with the first type of input transducers, light dependent resistors or LDR in short. As the name suggests, light dependent resistors have resistance which depends on light. Means the value of resistance will be changing in light and dark condition. In this lesson we are going to learn how these LDRs work and how we can use them in our circuits. But before starting, I want you to first revise resistors. Remember resistors from the previous chapter? What is resistors? Resistors are the devices which control the amount of current flowing through the circuit. The more the resistance, the lesser will be the current, right? You can see or you can find the resistors in broken toys. So many of you in your childhood have seen this type of resistor inside the broken toys. And the symbol of resistor is this rectangular box. This type of resistors are also available in the school lab. So resistors control the current. And as we learned in previous chapter, Ohm's law, that the resistors are made up of some metallic conductors whose value of current is directly proportional to the potential difference or the voltage of the battery applied to that resistors. Means if you keep increasing the voltage, the current will also start increasing. Type of resistors are called ohmic resistors and their value remain constant, right? And also we learned the formula for ohmic resistor is V is equals to IR. I'm sure you can recall all these things from the previous chapter. Now moving on. What does LDR do and how they do it? LDRs do not have resistance like these metallic conductors which have constant resistance, but their value of resistance depends on the light falling on them. Circuit symbol of LDR is similar to that of a resistor, a rectangular box which is enclosed in a circle with the two arrows on the top. What these two arrows represent? Can you guess? Yes, it represents light. That light falling upon a resistor changes the value of resistance. Now the question arises what it does. In LDRs, in dark condition, the LDR has high resistance, whereas in light condition, like when there is light, the LDR resistance reduced to very low. So if you plot the between the two quantities, that is resistance and light intensity, the resistance will be very high when light intensity is low. Means in the dark condition resistance is very high, but as the light increases, the resistance decreases remarkably. Now the question arises why it happens, like for what reason the resistance value of an LDR keeps changing according to the light falling upon it, right? So what makes the LDR behave like this? Means high resistance in dark and low resistance in light condition. It is actually because of the material it is made up of. Do you remember that there are three types of material? Materials are divided in the categories according to their electrical conduction, right? I'm sure you remember it from your previous science classes. What are those type of materials? The first type is insulators. So what is inside insulators? Actually, in insulator there are not enough electrons which can allow electricity to pass through it. Then the other type of material is conductors. What is inside conductors? Basically, conductors have plenty of electrons in them, right? Then comes a material which is in between insulator and conductors. That is semiconductor. Actually, it is neither 100% insulator nor conductor. Let's take a deeper look why some materials are semiconductors. We all know that there are electrons near to the nucleus and there are some electrons which are further away from the nucleus. Right? If in your previous in your chemistry classes you must have learned it. The electrons which are near to the nucleus are very tightly bound. They are called valence band electrons. Then the electrons which are away from the nucleus, they are loosely bound and they are called conduction band electrons because they contribute to the electrical conductivity. Then there is an energy gap in between these two types of electrons, right? So more the number of electrons in conduction band, more electricity a material can pass. I hope you understand these basic things. So what happens in LDR? In LDR, when light falls upon LDR, light is a form of energy. The electrons in the valence band receive this energy and jump through the energy gap, right? So because of the light energy, they are energized and now there are more electrons in the conduction band. That's why they can allow the more current to pass through, and therefore the resistance of the LDR decreases. I hope you understand this process. Yes, so now students, you must be wondering that what is the application of LDR, where we use it in our daily life, right? What is the purpose of studying all this? Have you ever wondered that when you use your mobile phone and when you are talking to someone, the screen light turns off, right? But when we are using your mobile phone in your hand, what happens? The screen light turns on very brightly. There comes the role of LDR. Yes, you get it. Inside our mobile phones, there are LDR fitted, which actually are basically sensors, light sensors. So how they use it? In the mobile phone, the circuitry is very complex, but here I'm going to show you the circuit, which is very simple. Remember, this is the symbol of LDR. Here I have connected LDR with a bulb. This is not a normal bulb. It is actually the mobile phone screen light. Okay, both of these circuit devices are connected in series with a battery of potential difference 10 volt, let's say. As you remember from series and parallel combination, in series combination what happens? Voltage basically divides, right? So in this circuit, the potential difference is shared between the two devices, LDR and the screen light. Now what happens? How this circuit works? In the light conditions, the resistance of this LDR will be very low. Means it will allow the current, or it will take very little energy to pass the current to the screen. So what will happen? Because of less resistance, the potential difference across the LDR will be very less. Remember, V is equals to IR. So in the light condition, resistance will decrease. Also, the potential difference across the LDR will decrease, right? Which will allow the current to pass through it, and the most of the current will reach to the backlight screen. Now it will have very high voltage, and therefore the lamp will be on, means your mobile screen will turn on very brightly. Now what happens in the opposite case? In the opposite case, if you hold your phone in the darkness or near your ear, the light falling upon this LDR will be very less, right? And we learned that in LDR, less light means high resistance. High resistance means that it will not let the current to pass through the lamp. Also, high resistance means high voltage. Again, I am repeating, V is equals to IR, Ohm's law. So most of the voltage will be dropped across this LDR and the less voltage across the lamp. That will cause the screen light to get dimmer. The same phenomena happens in the garden lamps. Garden lamps or even in the street light lamps, you must have noticed that they turn on as soon as the night falls upon them, right? Or when there is dark light. And in the daytime, these lamps, they are turned off, means they are working exactly opposite our opposite of that of backlight screen, right? Why it happens? It happens because of the logic gates. I will explain to you in the next topic. Until then, keep this mystery in your mind. Yes, I hope you understand LDR. Let's start the new type of input transducers, which are thermistors. Thermistors means thermal sensitive resistor. Just like LDR, there are also abbreviation of three words: thermal sensitive for resistor. So in LDR, the value of resistor changes according to the light. In thermistor, the value of resistance changes according to the thermal energy in the surrounding. Can you recall where you heard this word before? Yes, in grade 8 physics, thermal physics portion, we learned about thermistor-based thermometer, where the value of temperature was changing the voltage produced by the material. So, in thermistor, the resistance decreases as the temperature increases. In LDR, resistance decreases as the light intensity increases, right? The circuit symbol is also very similar to that of LDR. Rectangular box means resistors, whereas this line represents change in temperature. So, thermistor's resistance changes according to the temperature or the heat energy. The working principle is also very similar to that of LDR. In LDR, valence band electrons get the energy from the light source. Here they get the energy from the heat source. Okay. So if you try to plot similar to LDR, the two physical quantities on a graph, resistance, here the light intensity is replaced by temperature. If there is less resistance, the resistance will be higher, and as the temperature increases, the resistance will decrease. So the resistance is dependent on the temperature over here. Again comes the question that why we are studying, what is the application of these type of thermistors. Thermistors are used in the circuit where we have to sense the surrounding temperature. Can you try to recall, try to think of, can you think of any appliance whose value, whose voltage current changes according to the temperature? Yes, fire alarms or ovens. They sense the temperature and according to that they operate. One of such example is that of a CPU cooling fan also. Maybe you have noticed that inside a desktop computer there is a cooling fan which starts working when the CPU becomes hotter, right? The circuit inside the CPU is little complex. So here I am showing you a circuit which is simpler. Just like in the case of LDR, here I substituted the LDR with this thermistor which is in series combination with the cooling fan, and both of these devices are connected across a 10-volt battery. Again, since they are in series combination, so the voltage will be divided between the two devices, right? So inside the CPU, what happens during the when you switch on the computer, it is not very hot. So if it is not very hot, means thermistor senses low temperature. Low temperature means high resistance. Because of this high resistance, it will not allow the current to pass through and reach the cooling fan. In this case, what will happen? Because of the high resistance of thermistor, it will take a lot of energy and most of the voltage will be dropped across the thermistor. Let's say from 10 volts, 9.9 volt will be across the thermistor, and the cooling fan will get very small portion of the potential difference. Because of that, this cooling fan will operate at a very low speed. So under cool condition, the cooling fan will work at a low speed. Whereas when the situation reverses, when you keep working on the computer and it gets hot, the resistance of this thermistor will decrease. So it will act as a short circuit and allow most of the current to pass through it. Now what will happen? The lesser potential difference will be across the thermistor and most of the energy will be received by the cooling fan. And now the cooling fan will start working at a very high speed. So this is how thermistors can be used in a computer cooling fan circuitry. The opposite case is used in ovens. In ovens, you may have noticed that when the certain temperature is reached, a click sounds comes, and that means the oven has stopped working. And after that, until the temperature remains same, the oven does not supply heat energy, right? So it is the opposite case. Again, what happens there? We need logic gates, and logic gates will be our next topic.